Hi everyone, so today we are going to start our final chapter, that is antenna theory. So this will be an introductory video where we will understand the working of antenna, only the working of antenna, like antenna works on what principle and how does it work, and some mathematical things also we will see. From next video onwards we will start studying about different kind of antenna. So in this video, this will be only an introductory video, so there might be a chance that in the examination from this particular video no questions can be asked, but this is very important for understand the further videos. So do not ignore this video, just have the patience, just keep on looking at the screen and just start learning. Okay, so in this video we are only going to see the introduction to antenna. So what we need to understand, we need to understand the radiation, that how antenna radiates. So what is the job of antenna? Job of the antenna is to radiate EM wave energy. When we started studying our first chapter, EM wave, there what did I do? I put a current carrying wire here. Then what did I say? That from this current carrying wire, magnetic field will be generated, then electric field will be generated, magnetic field, electric field, and in that manner our EM wave energy is being propagated. This is what I said. This wire was generating magnetic, electric and EM wave energy was being propagated. So this wire was your antenna. This wire was your antenna. So what is the job of antenna? The job of antenna is to radiate. And what is the meaning of radiation? The meaning of radiation is propagation of EM wave energy, propagation of EM wave energy in the surrounding. Propagation of EM wave energy in the surrounding. So that what this wire was doing? What this wire was doing? EH. This is what it was producing. So it was propagating EM wave energy in the surrounding. EM wave energy in the surrounding. Now how does this wire will do this work? That we need to understand. So now we need to understand the working of antenna. So kind of a basic intuition I would try to give, that how antenna works. Okay. So before that, let's see some basic things. What is that? Like there is a positive charge, there is a negative charge. You need to make electric field lines. I hope you know how to make electric field lines. So electric field lines will get out of the positive charge and will get into the negative charge. Similarly, it will get out of the positive charge, will get into the negative charge. There will be a lot of electric field lines. This will be also there, this will also be there. But as of now, we are making only two. Only two electric field lines we are making. And unless there is a time varying magnetic field, electric field lines never frame a closed loop. This we have already studied. Del cross E is equals to 0. Unless there is a time varying magnetic field. If there is time varying magnetic field, then electric field lines will frame a closed loop, but otherwise it will not frame a closed loop. So del cross E is equals to 0. This is what we have studied. And like some guys might be having the doubt, sir, this is closed loop only, no? Sir, you are saying that electric field lines never make a closed loop. Sir, this is a closed loop only, no? From positive to negative, this feels like a closed loop. No. What is a closed loop? That it should get out from the here and should get in here. That means if this arrow is going this way, then other arrow should have been going this way. Like there is no closed path, no? This is not a closed path. You see from here, you see the direction of arrow. One arrow is going this way, another arrow is also going this way only. So this is not a closed loop. In your magnet, what do you see? From N to S and from S to N. This is a closed loop. Yes, this is a closed loop, but this is not a closed loop. So I got this doubt in our telegram only, that sir, this is not a closed loop. So this is not a closed loop. So don't get confused. Okay. Now again here there is positive and negative charge. So from here as well, electric field lines will go there, and this is how the electric field lines will be framed. So what is happening here? What do you see? That positive and negative charge are there. They are coming close to each other. Initially this was the distance. Now this is the distance. Now this is the distance. They are coming closer to each other. Now again from positive to negative there will be electric field lines, and positive to negative there will be electric field lines. So they are coming closer. Now what happened is that they got superimposed on each other. Now they are on each other. Positive and negative charge are on each other. So what they will do? What will be the total charge now? Positive Q is superimposed in a negative Q. So positive Q minus negative Q. Total charge will be 0 here. Total charge will be 0. Total charge will be 0. But what is the process that is happening? That positive and negative charge was there was electric field lines. Again positive and negative charge is there is electric field lines. Again there is positive and negative charge, there is electric field lines. Now they are superimposed. So these electric field lines will certainly be there, no? That from positive some electric field lines were getting in, and now, sorry, from positive some electric field lines were getting out, and into the negative some electric field lines are getting in. So still that loop is there, no? Are you getting this point? At this particular point, there is zero charge, but still this loop was there, no? From positive to negative electric field lines were there, positive to negative electric field lines are there, positive to negative electric field lines are there. So same phenomena is happening here as well, that from positive to negative electric field lines are there. Suddenly what happened was they got superimposed. So now what it will feel like? It will feel like that here there is no charge. I am only making the equivalent of this guy. I am making only equivalent of this guy. That there is no charge. That means this is simple point only. Like there is no charge. Here there is no charge. Plus q and minus q. There is no charge. So this is a simple point only. But from here only it will feel like that some electric field lines are getting out and then some electric field lines are getting in as well. Although there is positive and negative charge superimposed, that means there is no charge here. But this phenomena started from here. That initially positive and negative charge was there, electric field lines were there. Then they came closer, still electric field lines are there. Now they got superimposed. But this electric field lines that has been framed, that will still be there, no? So it felt like that. This is, let's just say, we can call it dipole. What do you mean by dipole? Dipole means positive charge and negative charge. If positive and negative charge is there combined, we can call it a dipole. Okay, so this is a dipole. This is also a dipole. This is also a dipole, and this is also a dipole. So in this dipole, what is happening is that positive and negative charges are there. They are coming closer to each other, and electric field lines are there. Although they are not framing a closed loop, but when they got superimposed, at that time it felt like that from this dipole, some electric field lines closed loop is getting out. From this dipole, some electric field lines closed loop is getting out. Here initially positive and negative charges were here, so there was a closed loop. Then they came closer, there is a closed loop. Then they came closer, there is a closed loop. When they got superimposed, it felt like that some electric field lines closed loop is getting out of the dipole. Did you understand this point? A very important point. Your complete antenna theory is based on this analysis only. Positive, negative, go closer, closer, closer. This was the loop, this was the closed loop. Then it felt like that this loop has been getting out of the dipole. Right? So this was one point that we need to understand. We will certainly build upon this point, but like this one point you need to keep in mind. Now let's see some previous thing that we have already studied. So have you studied about standing wave pattern? Like I'm not talking about standing wave pattern of normal incidence. I'm not talking about standing wave pattern of transmission line. A normal standing wave pattern. Did we study about that? Yes. When we started studying this chapter, in the first 1 hour and 30 minutes, we only discussed about standing wave. That what is the actual meaning of standing wave. So this is how we represent a standing wave, right? This is how we represent. But there I told you, we always represent standing wave with respect to Z, and this only shows the magnitude. What is this? This is the magnitude. So here in this standing wave, what we are seeing is that here at Z equals to 0, you are having maxima, then minima, maxima and minima. And this distance is, we already know this distance is lambda by 4. So though distance we are not talking about. So in this one, maxima, minima, maxima, minima. In this manner we show it. But what is the actual scenario? What is happening? In the actual scenario, the wave is like this. Then in the actual scenario, like this is your mode of cos beta Z. This is your mode of cos beta Z. Although like expression doesn't matter, but here we have shown that what we have shown. Here we have shown your magnitude, but actual wave is like this. And I showed you a simulation as well. I showed you an animation here as well. That actual wave is like this. Now this is the picture at a certain time t equals to 0. Now just as you click on the time button. What will happen is that this node will go down, this node will stay here, this node will go up, this node will stay here, this node will go down. Then it will go down, 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 then it will go up, this will come down, and then it will go up. In that manner, it will keep on going. So this is a standing wave. The wave keeps on dancing, and we can show you the animation here as well. Again, I am showing the same animation. So you can see that these two nodes are fixed. This node is also fixed, this node is also fixed. But if you keep your eye on these nodes, if you keep your eye on from here, if you see, so this node is going up, going down, this node is always fixed, this node is always fixed, this node is also fixed. But if you see this peak going up, going down, going up, going down, so that's why we call it standing wave. This wave is not traveling, this wave is standing at a certain point only and going up, going down, going up, going down. So they are dancing in up, down, up, down. That's why we call it standing wave. This is not your traveling wave. So a forward traveling wave and a backward traveling wave, when they got superimposed, they made a standing wave. So this concept we have already seen. So just I wanted to again I just wanted to revise it, that how do we frame a standing wave. Here I did not show you how do we frame a standing wave, here I only showed you what is the meaning of a standing wave, right? So the meaning of standing wave you have understood. So just it was a revision, those who have already studied, for them it would be a cake book. So yeah, okay. Now let's see the standing wave on a transmission line, but before that let's understand the meaning of antenna. So what does antenna does, that I have already told you. So antenna will radiate EM wave energy, but how it will radiate EM wave energy? So first we will give it a voltage and current. So we are giving it alternating, or you can say time varying. Alternating current means AC current. I naught sin omega t, I naught cos omega t, V naught cos omega t, V naught sin omega t. So when you give it a VI, it will generate EH. But the thing is, when you give it a EH, it should generate VI as well. Vice versa should also be true. That to an antenna, if I give V or I, it should give me E or H. But vice versa is also true, that if I give E or H to it, it should give me V or I as well. Okay, so this is the meaning of antenna. So that we will study how does it makes EH, and when we give it EH, how it makes VI. Although questions will not be asked from this particular topic in the examination, but still it is important to understand the chapter in a good manner, right? Now we have studied EMFT, right? In the whole EMFT, where did we give VI? In the whole EMFT, where did we give VI? Do you remember? Yes, in transmission line, right? In transmission line, we were giving VI. Now this transmission line, in this transmission line, we will give it VI and it will generate EH. To this transmission line, we will give VI and it will generate EH. And how does it generate EH? That we need to study. And where at that time, our standing wave pattern will be used. Because on transmission line, what do you see? You always see a standing wave pattern. So this is my transmission line. I apply a voltage source here. It could be anything. It could be your some V naught cos omega t. So I am giving a time varying voltage source here to this transmission line. This transmission line is open circuited, like there is no load. There is no load. So what will be your voltage reflection coefficient at load only? That will be ZL minus Z naught, upon ZL plus Z naught. So that would be 1. So at the load you will get maxima. Which maxima? Voltage maxima you will get. All this we have already studied, and if you haven't studied this thing, then you are missing out on a lot of things. Like let's just say you are directly jumping onto antenna, then that would be a foolish idea. If you are not studying transmission line, even for your gate examination as well, it will be a foolish idea. Like transmission line will be coming for 4 to 5 marks. Certainly it will come for 4 marks, and antenna will hardly come for 2 marks. So if you are dropping transmission line and directly studying antenna, then first thing you will not be able to understand antenna in a good manner. Secondly, it will not be a good idea for your gate examination. Okay, so first study a transmission line, otherwise there is no meaning of studying antenna. Yeah, so what I was saying, here we will get a voltage maxima and current minima. So both of the patterns I have made here. But this what we have shown, we have only shown the magnitude, because when we draw the standing wave pattern, we always show the magnitude. So yeah, this was our open circuited transmission line. So here we are getting voltage maxima, minima, or you can say current minima, maxima. In that manner we are getting. Now you let me know one thing. So what is the actual waveform? Actual waveform is this. If I only talk about the voltage waveform, I am making the voltage waveform. Actual voltage waveform I am making. So actual voltage waveform is like this, right? Actual voltage waveform is like this. So from 0 to lambda by 4, if you start from here, this is your y equals to 0 and y equals to L. So from 0 to lambda by 4, at a certain time, I am saying that here there is positive charge. At a certain time, here there is positive charge from 0 to lambda by 4. Then how much charge will be there on this point? Here there will be negative charge only, no? Are you getting to understand what I am saying? What I mean to say is that you see this simulation, you see this animation. Can I stop it anyhow? Yes, I can stop it. So this is your waveform at a certain time. So at a certain time, till this point, if you say there is positive voltage, what I mean to say is that this is your lambda by 4. This is your lambda by 4. So till 0 to lambda by 4, there is positive voltage only, no? And after that, lambda by 4 to 3 lambda by 4, there is negative voltage, because this is your 0 point. This is your negative and this is your positive. So what I mean to say is that from 0 to lambda by 4 there is positive voltage, then there is negative voltage, then again there is positive voltage, then again there is negative voltage. This is the phenomena, right? Now what will happen? Just as you click on the time button, again let me start. Yeah, so after some time what happened is that this point from 0 to lambda by 4, from 0 to lambda by 4 became negative, from lambda by 4 to 3 lambda by 4 became positive, then from 3 lambda by 4 to this point it became negative. So first it was positive, this was negative, then this was positive. Now what is happening? This has become negative, positive, negative. So this cycle is keep on going. And this is the standing wave pattern that you are getting on transmission line. So based on that I am saying first positive, then negative, positive. Then after some time what is happening? Negative, positive, negative. So this is what is going on, right? So when we, and credit goes to O Physics. Already I have mentioned the credits, ophysics.com HTML. So credit goes to them for the animation. So although in the diagram I have shown the magnitude, that every one of them feels like that they are positive voltage, but not actually they are positive. Actually this will go like this. This will go like this. So they are positive, negative, positive, then negative, then again positive, then negative. So in that manner it is going. So yeah. So what I wanted to show here is that let's show it on the next transmission line. So here I am showing it. So initially there is positive, 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 positive. Then there is negative, negative, negative. Then there is positive, positive, positive. Then again there is negative, negative, negative. In that manner we are going. It depends that how many positive, negative will be there. It will depend on the length of the transmission line. That if the length of the transmission line is pretty large, then a lot of positive, negative will be there. Let's just say the length of a transmission line is still lambda by 2 only. Let's just say this length of transmission line is lambda by 2 only. So some positive and some negative will be there. That's it. If the length is still lambda is this point. Then some negative, positive, then some negative. This kind of things you will be getting, right? Now here, just a second. Now can I call it zero potential? Can I call this as zero potential? Then with respect to that, here you are having V naught cos omega t. If this is a zero potential, can I call it ground? What I mean to say, this is your zero potential. Then with respect to that, here you are having positive or negative voltage. So for certain time, like for 0 to pi by 2, this will be positive, then after that it will be negative, right? This node I am calling 0. So all these will also be at zero potential, no? This will also be at zero potential. What I mean to say is that with respect to this potential, I am defining this potential as 0. This I am taking as my reference. This is my ground. So this I am calling as ground. So if here there is positive voltage, let's just say there is some 5 volt. Now here there is ground. That means 0 voltage is there. So can I define it as a negative potential? With respect to this positive 5 potential, can I define this as negative potential? Certainly I can define. Now here there is minus 5. So this will be defined as positive potential. This is a very simple concept of network analysis, nothing else. I am calling this as ground. This is my ground. So if I am defining this as positive, then this will be negative. If I am defining this as negative, this will be positive. If I am defining this as positive, then this will be negative. And next will be positive. Did you understand how did I make negative positive here? This is just my reference point. If this is at higher potential than this guy, that means this is positive, then this I can define negative. This is negative, then this I can define as positive. So here now what will happen? Positive, negative is there. That means there will be electric field lines. From positive to negative, there will be electric field lines. There will be electric field lines which are having direction downward. Now here there will be this electric field lines having upward. What is our target? Our target is I will convert V. What I am giving from here? I am giving from here Vi. What I need to get EH. Although we are only taking V in action and E in action, we are not talking about I. Neither we are talking about H. Here I am talking about electric field lines. Here I am talking about voltage only. So V and E we are talking about. As of now we are talking about V and E only. So what I can see is that from V I have generated E. But what you will see here is that whatever the positive lines you have created, whatever these lines you have created, in the same manner, in the opposite direction, another E lines are there. And here as well, in the opposite direction, another E lines will be there. Then again in the opposite direction there will be another E lines. So E and H are cancelling, sorry, these E lines which is in this direction and these E lines which are in this direction, they are cancelling each other's effect. Say yes or no. So resultantly total E here is 0. So what was our target? Our target was E should be radiated, but that we are not able to achieve. Why is that so? Because there is EH, in that manner there is EH, and there is very less space between that transmission lines. Like this space, this particular space is pretty low. Between the wires of transmission line, the space is pretty low. So electric field lines are cancelling each other's effect. This space D is pretty low. So E lines are certainly there. Positive charge, negative charge, E lines is there. Positive charge, negative charge, E lines are there. But effective E lines are 0. So our target was V or I should be converted into E and H. But we are not going to get net E. So net E here is 0. Net E is equals to 0. So we are not able to achieve our target. So now what did I do? So these are two wires, no? This is also wire, this is also wire. Now I bent those wires. What did I do? I bent those wires. मैंने wires को मोड़ दिया. I bent those wires. In which manner? In this manner I bend these wires. So these wires have been bent now. Okay. So I am bending the wires. So all these things will not come in the examination, but certainly you need to understand that how your antenna is working. So at least the working you understand, then I guess you will feel good. Studying this chapter you will feel good. Otherwise you will never be able to understand that what is the meaning of an antenna, right? So now again here there is positive charge, positive charge, positive charge. So I made sure that when I bend it, so I am bending it somewhere from here. I have bent the wire, but I am bending it somewhere from here. That I made sure that here only positive charge is there. Here only negative charge is there. Here, let's just say here there are two positive and rest all are negative. Rest a lot of things are negative. Then another positive will come, then more negative would be there. And certainly here is two negative and a lot of positives are there. Negative. So in this scenario, what will happen? They will certainly cancel each other's effect. Like electric field lines will be there in this direction. These electric field lines will be there in this direction. These electric field lines will be there in this direction. And more electric field lines will be there in opposite direction as well. So they will cancel each other's effect. And the distance is also very small. The distance between these two transmission lines are also very small. So they will cancel each other's effect. But here what will happen? The bending wire. What will happen? From here, electric field lines will be there, that will be getting in to this side. Electric field lines will be there, that will be getting in here. Electric field lines will be there, that will be getting in here. That will be getting in here. And this electric field lines will be getting in here. Now, with respect to time, what will happen? This positive will go down, and after some time it will become negative. I am talking about this positive only. Okay. Here I should make it with a different color of pen. So after some time, this is a picture at a certain time. Just as I click the time button, what will happen? This will become negative. Not just as I click the time button, after some time, like the peak will come downward, this will go upward. So this will go upward, that will come downward, because here there is standing wave. So this peak will go down as well, right? So this is what we are saying, that this peak is going down. So that means here there was positive charge, that is becoming negative. So this is what is happening, negative. Then what will happen? From positive to negative, from positive to negative, from positive to negative, from positive to negative. And this is happening with respect to time only. What I mean to say is that at some times your electric field lines were in this direction. After some time the electric fields have been in this direction. And eventually what will happen? It will frame a closed loop and it will be getting out of this wires, or you can say bend wires. What I mean to say is that here there was total net E was 0. So I was not able to generate EH from VI. But here when I bend the wire, this is positive, negative. I will show you animation as well. Okay, don't worry about that. So first there was from positive to negative, there was the electric field lines. Now from positive to negative, from down to up there is electric field line. So kind of they are framing a closed loop. Like if you see this thing, so kind of they will frame a closed loop, and then it will get out from the wires of the transmission line, you can say. And now these two bend wires, these are known as arms of antenna. So this is your antenna only, that you wanted to generate E and H, but effective E and H from V and I, we have generated E and H in the surrounding. So kind of this phenomena you will see. They have bent the wire as well, but they did not bend the wire perfectly. They did not bend the wire at 90 degree. They have also bent the wire here. So there is EH. Now with respect to time, what will happen is that after some time this will become negative. This will become positive. So now the field lines will go in this direction as well. Then they will frame a closed loop, and in this manner it will get out. You can see from here, this is the direction that they have made, and this is the direction that I have made. So from these wires, the electric field lines are getting out. Let me show you the animation as well. How the field lines will be getting out. Look, this is your antenna. Again, credit goes to Wikipedia. So this is your antenna. This is a dipole antenna. Here there is positive, negative. So after some time, this is becoming negative. This is becoming positive. You see, you keep on looking your eyes at this node. Positive, negative. And what is happening? Electric field lines are getting out. So here we have only shown the electric field lines. The same phenomena will be happening with magnetic field lines as well. But I don't want to spend much time here. Why is that so? Because that is not important for your examination. Like no question can be framed from this particular concept. I don't think any MCQ or NAT or MSQ can be framed. But still, if you want to understand the working of antenna, then that was important. So from positive, negative, electric field lines are getting framed, and then they are getting out of the wires. So this is your antenna only. So this circles, this what we have made, this box that I have made, these are your arms of antenna, or you can say this is my antenna only. Are you getting this point? That how they are framing a closed loop of E. Kind of closed loop of E they have framed. So EH we will get. And this is how we will see the radiation. Certainly for different kind of antenna, we will make the radiation pattern as well. We will understand the actual radiation. This only E we have seen. We have only seen the E. Electric field only we have seen. But what is the actual radiation? That pattern also we will make for different kind of antenna. So do not worry about that how the actual pattern would look like in 3D. So that visualization also I will give you. There I will try to show you the animation as well, and visualization also I will give you, and in complete 3D I will show you how the radiation of your antenna would look like. But as of now, we are not studying any specific type of antenna. We have just took a random antenna, that we took a transmission line, we give VE, VI, we wanted to generate EH. Then how did we generate EH from there? We need to bend the wire. Now this bending of wire is only your antenna. So antenna is made from your transmission line only. So till this slide we have spent 30 minutes. You don't need to remember anything. Just you go to know that this is how I can generate a closed loop of E field. Then I go to know what is the meaning of standing wave, that a node will keep on going up, going down. Then I studied the definition of antenna. Then I show it on a transmission line, that how does a standing wave pattern look like on transmission line. Then I can call it positive, negative charge. Effective E was there, 0. Certainly effective E was there, 0. So net B will also be there. But we did not discuss about B. What will happen here is that there will be time varying current. So what it will generate? It will generate a magnetic field. But if you call here there is minima of current, then here there will be maximum of current, then minima of current, then maximum of current. This positive, negative I am showing as per the minima and maxima. This is shown as minima of current. This is your maxima of current. This is your minima of current. So minima of current will generate an electric field, then maximum of current will generate an electric field, and both will cancel each other's effect. That's it. So same thing will, magnetic field. Minima of current will generate a magnetic field. Maximum of current will also generate a magnetic field. They will cancel each other's effect. So when they cancel each other's effect, net B will be 0. So here we are understanding only the phenomena with respect to E. But certainly the same thing will be happening with B as well. Here also the same things will be happening with B as well. But that we are not understanding. We will see it in 3D when we study about a specific kind of antenna. There we will see in 3D. We will draw E pattern, we will draw H pattern we will draw the radiation pattern in E plane and H plane, and then we will see how does the radiation look like in 3D, right? So till now you don't need to remember anything, you just have understood the working of an antenna. No question will be framed from this particular topic in your examination. And we have seen the animation as well, that how does an antenna radiate. Only a basic animation we have seen, right? So yeah, now we need to study spherical coordinate system. So those who have already studied it, they do not need to think about it because you already know. So you can skip next 3 to 4 minutes because you already know spherical coordinate system. And those who don't know, I will only give a basic idea that in spherical coordinate system what we need to do, we need to reach at this point. Usually how do we reach at this point? Some distance I will walk in x, then in y, and then in z. So I will reach this point P. But in spherical coordinate system, what I will tell you is that making an angle of theta from z axis, you jump in the direction of r. Making an angle of theta from z axis, you jump in the direction of r towards point P, such that if you take the projection of point P on xy plane, then it should make an angle of phi with x axis. So this statement we have already seen our spherical coordinate system. So here also I am telling making an angle of theta from z axis. Now from z axis you can make angle theta in any direction. Someone will say that I will make angle theta in this direction. Someone will say I will make angle theta in this direction. Someone will say I will make angle theta in this direction. So you make an angle of theta and jump in the direction of r by making sure that if you take the projection of point P on xy plane, then you should make an angle of phi with x axis. Now I have given this condition that you need to make an angle of phi with x axis. So now it is certainly sure that you need to jump in this direction only. So from O to P if you need to go, then making an angle of theta in the direction of r, making sure that projection is making an angle of phi, you will reach this point P. So this is your spherical coordinate system. Here what was your x? X was equals to r sin theta cos phi, and y was equals to r sin theta sin phi, and what was your z? R cos theta. And from there we made this table. Here I am not writing what is coming here, that you already know. Here what will come? Sin theta cos phi. Here what will come? Sorry, this is your sin theta sin phi. Here what will come? Sin theta sin phi. Then here cos theta. Now what you will do? You will differentiate with respect to with respect to theta. So first you will differentiate with respect to theta. So what will happen? Here will come cos theta cos phi. In the next cos theta sin phi, and then minus sin theta is there. Then you will differentiate with respect to phi. So here what will come? Minus sin phi. Here what will come? Cos phi, and then this will be 0. But you don't need to remember this matrix for spherical coordinates, for antenna. If you are studying antenna, then you do not need to remember this matrix. Only this last row you need to remember. Only this last row. So from this row, what do you get? Az cap is equals to cos theta ar cap minus sin theta a theta cap. So this thing I will be using in the derivation. That's why I told it here. That in the derivation I will directly write it, so no one should question that from where this came. This came from spherical coordinate system, and I have again told you, right? So only this much of spherical coordinate system will be used. Rest you need to know the limits as well, that theta goes from where to where. Theta goes from 0 to pi. Phi goes from 0 to 2 pi. Here no equal sign can be there. Sorry, this equal sign will not be used. Here equal sign can be used. Here equal sign will not be used. And what about r? R will be going from 0 to infinity. So this we have already seen in a very good manner, in a very in-depth manner. We have already seen this spherical coordinate system. We have spent around 2 hours. So that is very important for your examination purpose as well. And what about the ds vector? So a lot of ds vectors are there, but I will write down only one ds vector here. Yeah, so these were the limits. Now we can write down about ds vector as well. So ds vector will also be used. So that we can write down on next page. So along with the ds vector, curl operation will also be used. So this is your curl operation, del cross A. So del cross A, this is how we write it. If this is your A vector, which is given in the direction of r, theta and phi, then this is how you can write down your del cross A. A trick also I have told. So spherical coordinate system, if you want to watch, you can watch there, right? So and what about your dl vector? Your dl vector was dr in r direction. First you go dr, then r d theta, then r d theta in the direction of theta, and then in the direction of phi, that would be r sin theta d phi, r sin theta d phi. So this we proved as well. We worked in certain directions, and then we proved that how we are getting this. And ds vector, there could be a lot of definition of ds vector, but what will be used, that definition only I am going to write down. Like there are a lot of definition of ds vector, that how do you write down ds vector? That's r square sin theta d theta d phi ar cap. And if you need to write down with respect to a phi, then what you will write? R dr d theta. If you need to write down with respect to a theta, then what you will write? R sin theta d theta dr. So what will be used? We need to write down in the direction of AR cap. So in our analysis, always we will write down our ds in the direction of AR cap. So that would be r square sin theta d theta d phi, and in the direction of AR cap. So a lot of definition are also there, but those we are not writing, only this will be used. So from spherical coordinate system, mostly these things will be used. But what I highly recommend is that you should study coordinate system in a good manner, because questions can be coming from this particular topic. Okay, so yeah, these are the mostly used things from coordinate system, from spherical coordinate system in chapter antenna. I'm not saying in your final examination, but in the chapter antenna, mostly these things will be used from spherical coordinate system. Okay, now let's study about current vector. So current is a tensor quantity. In the first lecture I told you current is a tensor quantity, but now I have shown here current vector. Current vector in a infinitesimal wire. Infinitesimal meaning very small. What is the meaning of infinitesimal? Very small. So in a very small wire, you need to define a current vector. What is that? So there is a wire which is placed along L axis. Like there is X axis, there is Y axis, there is Z axis. Now I am placing a wire along L axis. Now in this wire, I current is flowing. This is your wire. This is your wire. In this wire, I current is flowing. Now what I will do? I will take a very small portion of this wire. I will take a very small length. That length is dl. Now in this dl length as well, I current is flowing. In this dl length as well, I current is flowing. So I have taken a small length dl where I current is flowing. So now how do I define my current vector? So my current vector would be I dl. But since it is a vector quantity, current is tensor, and this is a vector. So which has to be vector? This has to be vector. dl has to be vector. And what is the direction of dl? What is the direction of dl? What is the direction of dl? Direction of dl is equivalent to direction of current. Okay, is equivalent to direction of current. It is a very simple thing. Actually, I thought that I should not make a separate slide, but when I will write down one expression, I will write down the expression of magnetic vector potential. So there I will be using it. So that's why I thought that rather than explaining there, here only I will explain. So what do you mean by current vector? There is a wire which is placed along L axis. I took a small portion of that, only small portion, dl portion I have taken. In that dl portion as well, I current is flowing. So how do I define our current vector? So that is defined as I dl. I dl. This is not dot product. This is multiplication. I dot dl. I into dl, you can say. I into dl. Okay. And here current cannot be a vector quantity. So dl is a vector quantity. So direction of dl shows the direction of current. Okay. So if you need to define current vector here, if you need to define current vector for this particular wire, then how will you define it? Again, you have taken a small portion dl here. So what will be your current vector? I into dl. Now can I write down dl as, since this small portion I am taking in the direction of z, so can I write it down as dz? And what will be the direction? The current is flowing in the direction of az gap. Did you understand? How did I define this current vector? The current is flowing in the direction of az gap, and I have taken a small portion dl which is in the direction of z only. So here dl is equals to dz. Here this is question A and this is your B. So here I am taking a small portion which is placed along x axis. So this small portion is dx. Now current is flowing in the direction of ax cap. So can I define the current vector as what I am defining? Current vector. So I current is flowing in the direction of x, and small portion I have taken on this wire which is placed along x axis. So if it is placed along x axis, then I can say that I have taken the small portion to be dx. When it was placed along L axis, I took the small portion to be dl. It was placed along z axis, so I took the small portion to be dz. Here dx. And in which direction current is flowing? Ax cap, az gap, here al cap. Here I could have told that it is my al cap. So I could have defined this current vector as I dl al cap. Okay. So this current vector will be used somewhere. So where it will be used? Here it will be used. So magnetic vector potential, have we seen about it? Yes. In when we were studying about Maxwell's equation, there we solved a problem on this magnetic vector potential, and there I told you later on it will be used somewhere. Where it will be used? Here it will be used in our antenna chapter. Okay. So what is your magnetic vector potential? So from where did we get it? We always know that our del dot B is always equal to 0. So if a divergence is 0, if a divergence is 0, so we know two things, that our DC is 0 and CG is 0. So divergence of curl is 0, curl of gradient is 0. So divergence of curl is 0. Divergence of curl is 0. That means B has to be curl of something. B has to be curl of something. And what is that? That is your magnetic vector potential. So B is the curl of magnetic vector potential. So here B is equals to del cross A. Better what I should write, B is equals to mu H. So from here what you are getting, H is equals to del cross A divided by mu. This will be used in our derivations. Okay, in our derivations this will be used, right? Where what is A? A is the magnetic vector potential. Magnetic vector potential. So for a current carrying wire, what is this? This is your current carrying wire. For a current carrying wire at a distance r, at point P, you need to write down your magnetic vector potential. How will you write that down? So that I will tell you. Current carrying wire. So for a current carrying wire at a distance r, at point P, I need to write down my magnetic vector potential. So that I need to write down. So how will I write it down? So what I'm going to do, I'm going to take a small portion dl. I'm going to take a small portion dl here, and that magnetic vector potential is defined as first mu will come, mu I dl upon 4 pi r, but this is a vector, so here vector quantity. So this is your, what is this? This is your current vector, right? Current vector of infinitesimal wire. So this is your current vector. So this is the formula of this is the formula of dA, and if you need to calculate A, then you just need to integrate. So this is your formula of dA, which you need to keep in mind. So this is the first thing from the whole chapter. Those who have studied coordinate system, those who do not study coordinate system, they need to remember this thing as well. But those who have studied coordinate system, so this is the first thing that you need to remember, this formula. Also this should be in your mind, but this, I guess this is already there in your mind, that B is equals to del cross A, so from there you can find the value of H as well. But this should be there in your mind. So this is the first thing which you need to remember in the chapter of antenna. The very first thing. What is your magnetic vector potential at a distance r from a current carrying wire at point P? That is mu I dl 4 pi r. And what is this dl? dl is the small portion of wire that is taken. Now this axis I don't know. Let's just say this is your z axis. So what will be the direction of dl? Like if it is z axis, then direction of dl will be az gap. So what is this dl? This is the dl, that is a small portion that is taken along the wire, and the direction of dl is along the, so the direction of dl is same as the direction of current, right? So this formula we need to remember. And how will you keep it in mind? That confusion will be that sir mu will come or not. When I was a student, there was this confusion for me that sir mu will come or not. So what I used to remember is that sir del cross A is equals to mu H, and in the formula of H there is no mu, so certainly mu will come in the expression of A. Like expression of A, del cross A is equals to mu H, you know. So in the expression of A, mu will come. So all the confusion will be there with this mu. You will forget this mu. So that will be the confusion. So mu ideal upon 4 pi r. Okay. And what was the formula of H? H was I upon 2 pi r. No? Formula of H. I told you, you don't need to remember it, but it was I upon 2 pi r for a current carrying wire of infinite length. Current carrying wire of infinite length. So formula was I upon 2 pi r. So in the same manner you can try remembering it, but eventually you need to remember it. I am just telling you the way to remember, but anyway at the end of the day you need to remember the magnetic vector potential formula, because from the derivation purpose, if I talk about derivation, in the next lecture we are going to see some derivations. So from the derivation purpose, only this is the point from where they can ask some question. What I feel is that they can ask you to define the magnetic vector potential of a particular antenna. A current carrying antenna, they can ask the value of magnetic vector potential at a certain point. This is what I feel from the derivation. Later on we will develop some formula, so questions will be coming from those formula only. But from the derivation, if they want to ask something, then this is the thing that I can expect that they can ask. Well and good. Okay. Now let's see the some mathematical result we are going to see. So very important. Like for numerical purpose, this is very important. This you must have studied in mathematics as well. But here also, this is my duty since I am teaching EMFT, so you need to study it. So your integration is from 0 to pi by 2. Take care of the limit as well. Integration is from 0 to pi by 2. Sine to the power m theta, cos n to the power n theta d theta. So what will be the result? What you need to do? You need to pick this limit m minus 1, m minus 3. In that manner, you need to keep on subtracting. Then you need to pick this limit n minus 1, n minus 3. In that manner, you need to keep on subtracting. Then what you need to do? Take the summation of both of the limits. Then from the summation, subtract 2. Subtract 4. So here odd number are being subtracted. Here even number is being subtracted. What is subtracted first? 0 is subtracted. 0 to 4 in that manner. And then there is a, then you need to multiply with k. And what is this k? K can have two value 1 and pi by 2. When it will have value 1? When the value of m plus n is odd. And when value of m plus n is even, then it will have the value pi by 2. How will you keep in mind? You will keep in mind that k can have two values, 1 and pi by 2. Second thing you need to keep in mind, that is m plus n. We need to see the value of m plus n. So now, if m plus n is odd, what is 1? 1 is a odd number. And what is 2? 2 is a even number. Here you can see 1 you can see, and here you can see 2. So if m plus n is even, then pi by 2. If m plus n is odd, then 1. This is how you can keep in mind, right? You will keep in mind that k can have two values, 1 and pi by 2. So 1 will come for odd and 2 will come for even. In that manner you can remember. So if I need to do the integration of 0 to pi sine cube theta. So first thing, you remember this formula, but for the limit 0 to pi by 2. Now if you draw the graph of sine theta, this is your sine theta from 0 to pi. Even if I do the cube, then there is no effect on the like peak value will be 1 only, and whatever that is happening from 0 to pi by 2, the same thing is happening from pi by 2 to pi only. What I mean to say is that if I integrate from 0 to pi by 2 sine theta d theta, will it be same as pi by 2 to pi sine theta d theta? Because what does your integration does? Integration tells the area. So this area and this area will be equal. Like 0 to 1 value, the way it is taking, in the same manner it is going down from 1 to 0 as well. So this area and this area will be equal, both will be equal only. Whatever the value you get, you will get it as 1 only actually. So whatever the value you get, both will be equal only. Same goes for sine cube theta as well. Cube theta as well. Same goes for sine cube theta as well. Why is that so? Because in sine cube theta, the graph can be something different. I don't know how does the graph will look like. But certainly from 0 to pi by 2, whatever that you get, from pi by 2 to pi, same thing you will get. Are you getting this point? Just by think as the graph. Just think with respect to graph. Don't remember any properties. I am not writing down any properties. Just think of the graph. 0 to pi by 2, pi by 2 to pi. You can forget the properties, but you can never forget the intuition. So the same thing will be happening from pi by 2 to pi as well. So can I write it down as 2 into 0 to pi by 2 sine cube theta? Say yes or no. Now I can apply my formula. Here there is no cos theta, right? Here there is no cos theta. So what do you think, what is the value of n? The value of n is 0. Let's just say this is sine cube theta, and here cos theta is also there, but the power would be 0, no? Power has to be 0, because cos theta to power, anything power 0 is 1. So in the multiplication, there is 1. So value of n here is 1. So if you see, value of m is 3 and the value of n here is 0. So what I need to do, I need to keep on subtracting. So 3 minus 1. Now will I do 3 minus 3? If I do 3 minus 3, then there is no meaning of this formula, because 3 minus 3 will be 0. So you need to stop where you are getting 0. So here I am stopping. So 3 minus 3 I am not going to do. That's it. Then am I going to do 0 minus 1? No, you don't need to go to negative value as well. Just as you started getting 0 or negative value, there you need to stop. Here I was having positive value, so I stopped there. That's it. So 3 minus 1 only I will be writing down. So 3 minus 1. What about in the denominator? So what is the value of n plus n? That is 3 only. So 3 minus 0, then 3 minus 2. Now into k. K I need to write. What is the value of m plus n? M plus n is 3. So 3 is your, what is 3? 3 is your odd number. If 3 is odd, then what you will multiply? 1 only. And this 2 is also there. So this 2. Did you understand how did I apply the formula? Right? So 2 was already there, 2 was already there. Now what about this 3? 3 minus 1, then 3 minus 3 I am not gonna write. Then m plus n is 3 only. So 3 into 3 minus 2 is equals to 1. So what I am getting? 4 by 3 should be there in your mind directly. Okay? This answer should be there in your mind directly. That 0 to pi sine cube theta d theta is 4 by 3. This will be used somewhere. And in your examination as well it can be used. So directly it should be in your mind that 0 to pi sine cube theta is equals to 4 by 3. And if it is not there in your mind, then you can apply this formula. What about this one? First thing, the limit is from 0 to pi. But we have studied the formula for 0 to pi by 2. Then we need to see the graph. So 0 to pi sine square theta. So sine square theta from 0 to pi will be like this only because all values are positive. What about cos square theta? Sorry, cos to the power 6 theta. So what is the graph of cos theta? This is the graph of cos theta, right? For 0 to pi, this is the graph of cos theta. For 0 to pi, this is the graph of cos theta. Now, if I am taking power 6, let us say here there is some value minus 1 by under root 2. If I take the power 6, what it will become? It will become positive. I don't know about the magnitude. The magnitude will be somewhat 2 to the power 3. That would be 8. So magnitude will be 8. That I don't care. But this negative sign will be converted to positive sign because minus 1 to the power 6. So this will become plus 1 by 8. Do you agree to this point? Basically, the value will become positive. So this negative value, if you take the graph of cos to the power 6 theta, then all these negative value will become positive. All these negatives value will become positive, right? Previously, these were the negative value, but those will be gone and all those value will become positive. So whatever that you get from 0 to pi by 2, same thing you will get from 0 to pi as well. Similarly for sine square theta as well. Whatever that you get from 0 to pi by 2, same thing you will get from pi by 2 to pi as well. Like this area and this area will be same. Similarly, this area and this area will be same. Do you agree to this point? Certainly you agree to this point. So certainly you can break it down. So now I can apply this formula, but into 2 and then the same magnitude. So if I call this as I, if I call only this as I, so then 0 to pi by 2, 2 into 0 to pi by 2, sine square theta, cos to the power 6 theta, d theta. Now what I need to do? I need to apply the formula. So 2 is already there, that I am writing 2 only. Now what about this? So first I need to keep on subtracting 2 minus 1. Will I go to 2 minus 3? No, negative sign, I am not going there. In the negative sign, I don't need to go. So that's it about this value. What about 6? 6 minus 1, 6 minus 3 and 6 minus 5 also I will go. Right? 6 minus 7 I will not go because that will make the value to be negative. Now divided by m plus n, that is 8. So 8 minus 0, then 8 minus 2 is 6, then 4 and then 2. Next will be 0, there I don't need to go, into pi by 2. Why pi by 2? Because m plus n, here what is m plus n? Just see this value, what is m plus n? 8. And if it is even, then pi by 2 will come. There is very easy way to remember this formula, m minus 1, m minus 3, then n minus 1, n minus 3 in that manner, then m plus n you do, minus 2, minus 4 in that manner you go, multiply with k. K can have two values, 1 and pi by 2. K will be 1 when m plus n is odd. What is the way to remember? 1 is odd, so odd. 2 is even, so pi by 2. So when you solve this, what you are going to get? From here, what we will get? So 2 into 1 into 5 into 3 into 8 into 6 into 8 into pi by 2. 3 into 2. So 5 pi by 128. 5 pi by 128. So when you solve it, you are getting 5 pi by 128. So this should be there in your mind. So that's why I kept it in box. This I am not keeping in box. This was just a question that if such kind of expression come in your examination, will you be able to solve this integration? Certainly you will be able to solve this integration. Okay. So this was a very important slide. When we study about radiations, so there it will be used. Like when we calculate about u, theta, phi, so there it will be used. Right. Now let's see the types of antenna, because from the next lecture onwards we need to study about specific antenna. So only two kind of antenna we are going to see, dipole and monopole. These are in your syllabus. Dipole antenna and monopole antenna. What do you think why these are called as dipole? Because these lines, these arms of antenna will make dipole. No? So this is how I will be showing your antenna. This is how I will be showing your antenna, and these are your arms of antenna. What this will be? This will be your arms of antenna. So here I am not writing it. So why we are calling it dipole? Because they will make dipole, no? Here plus plus will be there, here minus minus will be there. So they are making a dipole. What did I tell you? Plus and minus combined will make a dipole. So similarly, they are making a dipole, so that's why they are called as dipole antenna. This is the length of antenna. This is your L. This is known as length of antenna. So complete two arms combined, this arm and this arm. These two combined is making one length. So what this will be? L by 2. And what this will be? L by 2. So this is known as your dipole antenna. This is also known as center fed antenna. Center fed antenna. Why center fed antenna? Because this source is applied at the center, no? Like at the center is there is source, and then there is one arm, there is another arm. So two arms are there, one arm upward, another arm is downward, and in the center there is a antenna. Sorry, there is a source. So this source is at a center, so that's why it is known as center fed antenna. And this is your monopole antenna. What do you mean by monopole antenna? So there is source, then there is only one arm of antenna, only one arm is there. This is your, what is this? This is your source, and then only there is one arm. What is this? This is your ground. And what is ground? Ground is a perfect conductor. Now you might be thinking that sir, this is a there is only one arm. There is only one arm. So only positive will be there at some time, or sometime negative will be there. So how it will make a closed line? I should not say closed line. How it will make a electric field which is going from positive to negative? Because there is only one arm. So this doubt might be coming in your mind. So that I will tell you how it is making a electric field like this. So when we study about monopole antenna, at that time it will be clear to you. But as of now, you just need to see the types. What all two types are there? Monopole and dipole. In dipole there are two arms. Complete length is L by 2, L by 2. Now this will be the length of antenna only, no? There is only one arm, so this will be the length of antenna. So this is your length of antenna. So in the question, if it is mentioned that length of monopole antenna is given as lambda by 2, so that means this length is lambda by 2. And in the question, if it is given the length of dipole antenna is given as lambda by 2, that means this length is lambda by 4, this length is lambda by 4, both combined is lambda by 2. So they will never write down that length length of one arm of dipole antenna. Nah, nothing like that. They will tell length of complete dipole antenna is lambda by 2. That means this complete length is lambda by 2, so this will be lambda by 4 and this will be lambda by 4. Is that clear to you? So this is your monopole and dipole. When we study about monopole antenna, then we say that it is here, there is ground. So with respect to ground, it is lying. Like with respect to ground, we have placed our monopole antenna. So this monopole antenna is placed with respect to ground. Okay. Now this is known as base fed antenna. This is the other name. So you can say from the base supply is coming. So that's why it is known as base fed, and this was known as center fed. So from the base, this is the base of antenna, no? If this is your antenna, this is your antenna, then this is the base. So from base supply is coming, and here the supply is coming from the center of antenna. And here this is the base of antenna, so from the base supply is coming. So this is known as base fed antenna, this is known as center fed antenna. Sometimes in the examination, instead of writing monopole and dipole, they write center fed and base fed. So that should also be there in your mind. Is that clear to you? Okay. Then we need to see now dipole and monopole antenna are there. Now based on the length as well, there is classification. Based on the length, antenna has the classification based on the length as well. So this is your length, no? This is the length of your, this is your length. This is your length of your antenna. So if the length is less than lambda by 50, if a length is less than lambda by 50, then it is known as infinitesimal dipole antenna. That means infinitesimal means very small dipole antenna, very small dipole antenna, and other name is Hertzian Hertzian dipole antenna. Hertzian dipole antenna. So in the next lecture we are going to study about this Hertzian dipole antenna only. When the length is when the length is less than lambda by 50, and when the length is between lambda by 10 to lambda by 50, lambda by 10 to lambda by 50, then it is known as small dipole antenna. And when the length is greater than lambda by 10, then it is known as large dipole antenna. Generally we need to study about this and this, we don't study about all this. Okay, so in large dipole antenna we study about lambda by 2, lambda by 4, or about all these things. So based on the length, this is the classification. So what we need to study? Two types of antenna, monopole and dipole. Now based on the length, if length is less than lambda by 50, very small, or you can say Hertzian dipole antenna. If length is between lambda by 10 to lambda by 50, that means that is known as small dipole antenna. And if the length is greater than lambda by 10, then that is known as large dipole antenna. What do you mean by lambda? From where lambda would be coming? So what is the frequency of this source? What is the angular frequency of this source? And from here lambda would be coming. Right? From omega what you can find? Beta. And from beta what you can find? Lambda. So lambda by 10, length should be greater than lambda by 10, between lambda by 10 to lambda by 50, and less than lambda by 50. So this is about our complete chapter. In the next, sorry, this is about our complete video, not chapter. So in the next lecture we are going to study about Hertzian dipole antenna. So from all this slide, what you can remember, what you need to remember, starting from the first slide, you don't even need to revise it. Okay, so forget about the first slide, forget about this first slide. Here from positive negative there is a dipole. This is how we are getting a closed loop. So this is something that we saw. Then this was standing wave pattern, then we saw the definition, then here we saw the standing wave pattern, and then we saw that net E and H if we need to get, then we need to bend it. So this is our antenna. So from here we understood this is our antenna. Then we saw the spherical coordinate system, that what all things we need to keep in mind. So this thing we need to keep in mind, the limit also we need to keep in mind. And then this is our curl operation, and this is the ds vector, this is the dl vector, this is how we write it down. Then we saw what is the current element. So in the wire there is a small portion, if I take, that would be idl, that would be the current element. And then we saw about the magnetic vector potential. So this is the first thing that we got to know. This will be used in the next lecture. So from here we will carry it. So this you need to keep in mind. What is that? Magnetic vector potential. How do you write down the magnetic vector potential? Because of a current carrying wire. And this mathematical operation is also very, very important. This you need to keep in mind. Here why I have written 3, this is 1 only. So 0 to y by 2 sin m to the power sin to the power m theta cos to the power n theta d theta. So how you will keep in mind, that you need to see. Okay, and then we saw the two types of antenna, dipole and monopole. This is known as base fed, this is known as center fed, this is known as base fed, right? And this is the length of antenna, this is the ground, which is a perfect conductor. So we will study about both of the kind of antenna, and based on the length, this is the classification. If very small, infinitesimal, then small, and then large dipole antenna. From the next lecture, we will start studying about Hertzian dipole antenna. Is that clear to you? Okay then, yeah. So from the next lecture, important things will start. From here, you just need to keep in mind, from this slide you need to keep in mind. If you need to revise, from here you will revise. Previous slide you can ignore. When you are revising, you will revise from here. That dA vector, then this mathematics, then this is the classification, and these are the length. Then we will start talking about Hertzian dipole antenna. Thank you very much. Okay, so let's meet in the next lecture.